Hey everybody, this is Mr. Becksterman. Today we're going to go over the Test 1 review in my math lab. So here's the first question. It says, what are units and describe how units can help to check answers and solve problems. So remember, units are things like feet or inches or pounds or meters or liters. They're anything that kind of describe how a value is applied there. So let's take a look at these here. It says units are words that describe the quality of something. Units are questions in a book. Units are words that describe what is being measured or counted, or units are atomic particles. So hopefully we know that units are words that describe what is being measured or counted. So if we're saying something is 3 feet tall, we're measuring something, right? We're measuring the length of something in the unit of feet. So for this one, we're definitely going to go with C. Okay, for the next part, it says describe how units can help to check the answers and solve problems and give an example. And I know that this is a little bit hard to see there. Let's see if we can kind of scroll in a little bit. But the first one here says consider a room with an area of 120 feet. The word square here means that the unit is feet. And that's not true, right? Because that means it would be in feet squared. So we know it's not that first one. The second one says consider a box with side length in inches. The volume of the box would be calculated in cubic inches. That's correct, right? Because cubic inches is inches raised to the third power, which is what it says right here. And the mathematical symbol to represent the unit of the volume of the box is inches cubed. So that does look like to be the correct answer. And for C, consider a speed whose units are miles per hour. Here it means that for every hour in time, the traveling distance is 1 mile. Let me see, miles per hour. So that is not true, right? Because we're not saying for every hour, we're saying that or we're not saying that the traveling distance is 1 mile. It could be any amount of miles, so that one's not correct. And then the last one is consider a box with the side lengths in inches. The volume of the box would be calculated in cubic inches. The key word is cubic inches, and that's raised to the second power, and that's not correct because cubic means raised to the third power. So for this one, we would definitely have the answer of B. All right. Okay, for the next one here, it says, how much will a person pay for 11.2 pounds of bananas at a price of $1.68 per pound? And the keyword here is of. Of is going to tell us to multiply these to find the total price. So what I'm going to do here is take out my calculator and just multiply those two quantities together. So 11.2 times 1.68, and that gives me $18.82, rounded to the nearest cent there, so 18.82. So it would be 18.82. And then for the unit there, you're going to do a drop down box, and it's going to give you the option of dollars or pounds. So we're going to pick dollars because that's how much we're paying. All right, let's take a look at the next one here. Okay, the next one says decide which of the two given prices is a better deal and explain why. It says you can buy shampoo in a 6-ounce bottle for $2.29, or in a 15-ounce bottle for $9.49. Excuse me. So I want you to try to figure out the price per ounce, because that's what it's asking, the cost per ounce. And go ahead and pause the video now, give it a try, and then we'll take a look and see what we did. Okay, so the word per tells us to divide. So if we do 2.29, that's the 6-ounce bottle, and we're going to divide that by the 6 ounces. We're going to get a cost of about 38 cents per ounce on that one. We'll do the same thing with the 15-ounce bottle. So we're going to take the 9.49 and divide by that 15, and that'll give us the cost in ounces. So that one's about 63 cents an ounce. So in this case, it's definitely going to be better to buy that 6-ounce bottle. And we have 38 cents and 63 cents. So the 6-ounce bottle is a better deal because the cost per ounce is 38 cents versus the 15-ounce bottle price of 63 cents, right? 63 cents per ounce. All right, let's take a look at the next one. Okay, so for the next one here, it says complete the following sentence with a power of 10 greater than 1. A liter is blank times as large as a picoliter. Well, they give us a little button there we can click. It looks like a little I symbol, and that's going to pull up this common metric prefixes here. So what we're going to do is we're going to go down to pico and see that that's 1 trillionth, or 10 to the negative 12. So that is a really, really, really small value compared to a liter. So when we're saying, so a liter is much larger, and really all we're going to do is just take that negative 12 and make it a positive, because the liter would then be 10 to the 12th times. It would be a trillion times, which is 10 to the 12th times larger than a picoliter. Just as a meter would be a trillion times larger than a picometer. And we could do that with any of the metric units. All right, let's take a look at the next one here. Okay, so next one says, Ruben says, 2 days ago, I was 20 years old. Later next year, I will be 23 years old. How is this possible? And we kind of look down here. So the first one says, Ruben spoke on February 28th and was born on a leap year. Well, every year has a February 28th. So it'd have to be February 29th before we could make a jump like that. And even that would be a 4-year jump, so that's not right. Ruben spoke on a leap year and was born on February 28th. That's the same thing. Pretty much it's this last one, and so that we know that's not true. Ruben spoke on January 1st and was born on December 31st. Now, really, if you speak on January 1st and you said it on December 31st, that sounds like a 1-day difference to me, but maybe you said it really late and you were born in the morning, so maybe you could round that to 2 days, right? So that could be true. And then, so if you were, let's say you're 21 on January 1st, what does that mean? That means that a couple of days ago, you could have been 20. And later next year, so if you go to the next year after you turn 22, and then you get all the way down to later until December 31st, that could get you all the way to 23. So C looks like it could be true. And the last one says, Ruben spoke on December 31st and was born on January 1st. That can't be true because 2 days before December 31st was not January. All right, so the answer for this one would be C. Okay, so for the next one, it says, in the following statement, express the first number as a percentage of the second number. In 2016, revenue for company A was $290 million, compared to $408 million for company B. So to write what percent of 290, or what is the percentage of 290 compared to 408? And the easy way to do that is just to divide here. That's going to give us the decimal, and then we can convert that to the percentage. So if you take the 290 and you divide by that 408, and then we're going to multiply by 100 in order to convert that from a decimal to a percentage. So that means that 290 is 71.1. We have to round this one up because there's a 7 right there. And the answer tells us to round to the nearest tenth. So this is going to be 71.1%. So 290 is 71.1% of 408. All right, let's take a look at the next one here. It says rewrite the following statement using a number in scientific notation. The number of different 8-character passwords that can be made with 26 capital letters, 26 lower letters, and 10 numerals is approximately 220 trillion. So they want us to write this in scientific notation. And remember, scientific notation means that we are going to put the decimal place to the right of the first non-zero digit of our number. So let's first write out 200 trillion. I usually like to go from the right side of this number when I'm writing it out. So 0, 0, 0. All right, so that's going to be the hundreds, 0, 0, 0, and thousands, 0, 0, 0. So right now, if I put a 1 here, we would be in billions, but we want to go to trillions. So another 3 zeros here, and that's going to put us in trillions, and it's 220 trillion. 220 trillion, because these are billions, millions, hundred thousands, and hundreds. All right, so if I want to put this in scientific notation, here's the decimal place. I'm going to move it to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to move it to right here because I'm going to move it to the right of the first non-zero digit. So we said 14, so this is going to be 2.2 times 10. And remember, we're going to have to use a positive 14 because this decimal place has to go to the right in order to make this number correct here. So that's it for that one. 2.2 times 10 to the 14. Okay, this next one says carry out the indicated operation and give your answer with the specified number of significant digits. So this one here is going to be, let's clear this up, 41 times 32.6. And so we get 1,336.6, and they want us to round this to 3 significant digits. So when we round it, we're going to start from the left and go 1, 2, 3. So we need to round it to here. So that's just going to be 1, 3, and then we round this one up to 4 because to the right of that is a 5 or higher. So it's just going to be 1,340. Remember, with whole numbers, we don't count those zeros to the right, so we can write that as 1,340. And that will be our answer. All right, let's take a look at the next one. Okay, for this next one, it says the average price of tuition and fees at a private four-year college and universities increased from $8,300 in 1988 to $24,000 in 2007. Calculate the relative change in price from 1988 to 2007 and compare it to the overall rate of inflation as measured by the Consumer Price Index. Right, so for the first part, it's just asking us to find the relative change in price. So I have a formula for that, and you should have this in your notes here. So the relative change is just the absolute change divided by the reference value. And another way to look at that is the new value minus the reference value divided by the reference value. Remember, the reference value is usually the older or original value. And here we're talking about the price. So we're talking about the 24,000 and the 8,300. So if I take my calculator and I do the new value, so the newer value is the 24,000 minus the reference value, which is the older value, which is 8,300. I get this, and then I'm going to divide by that reference value, so divide by 8,300. I get this, and then we're going to multiply that by 100 in order to convert it to a percentage. Remember to convert to a percentage because they want the answer in percent. We're going to multiply by 100. So that's going to give us, if we round to the nearest integer, it's 189%. So the price of universities from 1988 until 2007 increased by 189%. But remember that there's inflation, so we also want to take a look at what the overall inflation rate by the consumer index. So for that, we're going to use a different formula. Okay, now to find that relative change in inflation, we're going to basically do the same thing, except now we're going to use this table here. So we're going to take the newer CPI for the year minus the older CPI for the year and divide that by the older CPI for the year. So let's take a look at what values we're using. The CPI, the newer one for 2012, is 229 point, well, this one says 2012. That's just like an example one. Ours is going to be 2007. So ours is going to be 207.3. The 1988 will be 118.3. Just plug it in there. So we're going to do 2007. So 207.3 minus the one from 1988, which is 118.3. 118.3. That's our absolute change. And then we're going to divide that by the reference value. That's the older values. That's the 118.3. And I'm going to get this, and then we want to convert it to a percentage. So I'll multiply by 100. So this is going to round. If we round to the nearest integer, that will be 75%. And what that means is that from 1988 to 2007, the inflation has gone up 75%, but the four-year colleges have gone up much higher than that. And I didn't save what I wrote there, but it was a lot more than 75%. So that's kind of what they're trying to get you to be able to kind of compare and see there. All right, let's take a look at the next one here. Okay, and for this last one here, we'll look at the first three parts of it, and then I'll let you do the last three parts of that. This one says, the table below shows 8th grade mathematics test scores in state A and B. The scores are separated according to the sex of the students. Also shown are the state averages for both sexes. Complete parts A through E. Like I said, we're only going to do A through C here. The first one just says, which state had the higher scores in both categories? Well, this state for male and female had 277 and 246, and here state B had 279 and 248. So both of these had higher, so that would be state B. We'll mark there. The next one says, which state had the higher overall average across both scores? Here's the overall average, and that would be state A with 273 versus 269. So that's going to be state A. Now it says, explain how a state could score lower in both categories and still have a higher average score. Well, let's take a look at this first one. Is this overall average closer to the male or to the female here? And it's much closer to the male, so that indicates that maybe there was a lot more males here than females, because when we added up all of the scores and divided by the number of people, we got this. And in order to get, we're only 6 away, 273 is only 6 away from the males, but it is, what was it, 63, 53, it's like 27 away from the females. That means that we definitely had to have a lot more males here. And this one here, that 269, is pretty close right in the middle of males and females. So I would assume that state B kind of had a similar amount. So it says, explain how a state could score lower in both categories and still have a higher overall average. And we said that it would be C here. The state could have a higher percentage of students in the category that had the highest average score. So if we had a much higher percentage of males for state A, that could have given us our higher average there. Then they want us to verify that. Now they're going to give us a table here and say state A had 87% male and 13% female. That means for every 100 students, 87 are male and every 13 are female. And they want us to see how they would have gotten that average score. And what we can do is just take that percentage in decimal form, so that 87 is 0.87. We're going to multiply that by, that's the number of males, so that's by the 277. We're looking at state A. And then we're going to add the 13%, which we can write in decimal form as 0.13, times the number of females, which was 246. And if we do that, notice we get a score that is rounds to 273. And that is correct, because that's how much it was. Now they're going to ask you to do that for state B to verify that, and some other questions. And please let me know if you have any questions. I hope this helps. Good luck on the test, and we'll see you all on Wednesday. Thanks.